Question number 76. Let's read it. Decreasing order of bond angle of NH3, H2O and CH4 is. Student, in CH4 there are 4 bond pairs. Geometry, the shape is tetrahedral. The bond angle is 109.5 degree. When we talk about NH3, out of in case of NH3, there will be 3 bond pairs and 1 lone pair. That means the geometry will be pyramidal, and because of one lone pair there will be repulsion, as we know that the repulsion between lone pair bond pair is more than that of bond pair. So the bond angle will be little less than 109.5, and I'm writing the value here. The value of bond pair is 107 degree. Now when we talk about H2O, there will be 2 lone pair on oxygen atom and 2 bond pair. The shape will be bent. Here, there will be even more repulsion, because that repulsion that occurs between lone pair is even more than that of lone pair and bond pair. As a result, the bond angle here will be even less than that of NH3. I'm writing the value. The bond angle here is 104.5 degree. That means the correct order of bond angle is represented in option number 2. The highest bond angle is in CH4 and the least is in H2O. That means the correct answer is option number 2. Moving to next question. Consider the following statements. Azimuthal quantum number defines the three-dimensional shape of orbital. Principal quantum number determines the size of an orbital. Third shell of helium plus ion has 9 degenerate orbitals. Students, the correct statements are. So students, number 1, azimuthal quantum number, that is L, defines the three-dimensional shape of orbital. This is a correct statement. Principal quantum number determines the size. This is again correct. That is principal quantum number is N. N determines the size of an orbital, correct. And the third shell of helium plus ion. Helium plus ion is a single electron system. And we have already discussed that for single electron system, energy depends upon the value of N only. Third shell contains 3s, 3p and 3d. Here the energy of 3s will be equals to 3p will be equals to 3d. And number of orbitals present in 3s is 1. The number of orbitals present in 3p is 3. The number of orbitals present in 3d is equals to 5. That means total 9 orbitals will be of same energy, and the orbitals of same energy are called as degenerate orbitals. As a result, we can say that the third shell of helium plus ion has 9 degenerate orbitals. So all the given 3 statements are correct. That means the correct answer is option number 4. Moving to next question, which is question number 78. Let's read it. The potential energy of electron in the second orbit of Li2 plus ion is. So student, we know that potential energy is equals to 2 into total energy. Total energy is equals to minus 13.6 z square upon n square. 13.6 into z square, and for lithium 2 plus the value of z is 3, so 3 square upon n square. N is number of orbit, here it is second orbit, so the value of n is 2, so 2 square, which is equals to minus 30.6 electron volt. Now let's calculate potential energy, which is equals to 2 into total energy. That means 2 into minus 30.6 electron volt, which is equals to minus 61.2 electron volt. That means the correct answer is option number 3. Going to next question, which is 79. Let's read it. Maximum number of electrons present in a subshell is given as. Students, the total number of orbitals in a subshell is equals to 2L plus 1. Here we have to answer electrons. So the maximum number of electrons will be twice of the orbitals, because one orbital can accumulate one orbital accumulate maximum 2 electrons. So this will be 2l plus 1. That means the correct answer is option number 4. Moving to next question, which is 80. Let's read it. Isoelectronic pair among the following is. Student, isoelectronic. Here I'm writing the meaning of isoelectronic. Isoelectronic pair contains equal number of electrons. Number one, we have CO. The total number of electrons present in CO is 14, and the total number of electrons present in Cn minus is also 14. That means option number 1, CO and Cn minus is isoelectronic in nature. So the correct answer is option number 1. Also, let's consider the rest of the options. In case of N2 minus, the total number of electrons are 15. In case of O2, the total number of electrons are 16. In case of F2, the number of electrons is 19. In case of O2 minus, the number of electrons is 17. In case of NO, the number of electrons is 15. In case of CO, the number of electrons is 14. That means number 1 option is the correct option.